Hello?
Hello. I'm here. Whoa!
Okay, enough.
Here.
Enough, okay? Okay, so yesterday we talked about algorithm complexity, right?
Algorithm.
Yeah, so let's just review a little bit, okay, as a quiz. Okay, so I have two.
Games.
I have a number, yeah, a list of numbers, and I want to compute the sum. Okay, so I have two problems.
What do you have to do?
Look, don't shake. I mean, don't shake. So I have the there's a function f1 here, right? Look,
Yeah.
and this is number n. Okay, and I have a function for s equals 0, I in s plus equals I, return. Okay.
F on the outside.
Okay.
Yeah, big brain.
No. Okay, maybe make it this way. Okay, make it this way. N is a number. N is a number like 10. So then I want to calculate 1 plus 2 plus 3 plus till 10. Okay. So one way of doing it is this. Yeah. Range n plus 1 and plus I. Okay, return s. Yeah, this is one way of doing it. The other way of doing it, f2 and like return n times n plus 1 divided by 2. Okay, so can you tell me which one is better? There are two, both can compute the sum of the first n positive numbers. So which one is better? Just take a guess. Look, algorithm complexity, remember? We talked about that. So this is just looping the n numbers and then adding each numbers into the sum. And this is just using the mathematical equation. So which one is faster? Which one is better? Which one? Yeah, you know the answer. Yeah, which one is better? Remember we talked about the linear complexity.
What do you think?
Come on, give me. This is n. This is t.
That's interesting.
Okay, come on. This is linear.
Maybe.
What? Which one? Which one is better? Just guess. If n is a median, what this does is needs to iterate the numbers between 0 to a median and adding each number. And this one just putting a median there.
1 million.
Yeah.
7 0.
Yeah, I know. And put a median and compute a sum. So which one is faster? What do you think? In terms of computer, which one?
Wait, what's this one again?
Compute the sum of the if I put the
So you like 1 or 2 or 3 or 4 or 5.
Yeah. Look, if it's 100, yeah, then you know 100 times 100 plus 1 divided by 2, which gives you 50-50, right?
Okay, then this one.
This one is faster. Yeah, can you tell me why?
Because you can just do that easy.
Okay,
and
so
you don't need to do.
you don't need to repeat, yeah? Yeah, you are right. Yeah. This is the complexity here is O(n), right? Because linear, right? But this one is what?
Did you get that correct?
This one is O1 constant, right? And if you draw it on the ball, look. If you draw it on here, yeah, this is n, this is t. So what does it look like? This line.
T.
Eric, look,
Yes.
this line. What does it look like? This is 1. So the complexity will be just like that.
Regular.
Yeah. Yeah, that will be just like that. It doesn't matter if it's 1 million or 10 million, right? It's always 1, right? But this one is, if it's 1 million, it's very high. 10 million is even high. Do you get it? This is not linear. Okay, well done. That's very good. Okay. So today, going back to this topic, we are going to given two lists. A, like 1, 3, 5, 7, 9. And B, another list. 2, 4, 8. Okay, just like that. So A and B are two lists, but they are sorted. Yeah, look, they are sorted. So meaning each of these is already in order. So look, 2 is smallest, 2 is in order, right? Yes? 1, 3, 4 is increasing, and this is increasing, yeah? So the task is to merge these two, you know? Merge to sorted list. Okay? So our task is to merge it. So what's the answer here? Can you tell me what's the answer?
I don't get it.
So look, this is 1, 3, 4, 5, 9. Yeah?
Uh,
Increasing. This is 2, 4, 8. And I want to merge it together and it will be sorted. So,
what does that mean?
so look,
We
8.
need 1, 2, 3, 4, 5, 7, 8, 9.
Yes, but there's no 6,
I was about
right?
to. I was
Oh,
about
okay.
to say 6.
Okay. Yeah. So okay, I missed the 6 here. So the answer would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Okay, so you basically take every element from both and then make it sorted. Do you understand? Yes? Okay? Okay, so any thoughts how we do it? Any thoughts? How do we do it? If we are both sorted, we take, yeah? We want to take both elements from both lists and we want to make it sorted. The result needs to be sorted as well, in order. Okay, so one easy way would be if I put this onto the end, or this list onto the end, yeah? And then it becomes a list, but it's not in order, right? And then how about I sort this entire list? Yeah, it will work, right? Yeah? So how do we do it? Look, using the
Yeah.
define, merge, okay?
Always far.
Merge A, yeah? Look,
Yes.
comma B, what's this?
Column.
Oh, yeah. And then look, if I C, yeah, C is the list. If I do it A plus B, then you put this list here, yeah? This list will become 1, 3, 5, 7, 9, right? And then 2, 4, 6, 8, yeah? And what we need to sort this list, right? So Eric, can you remind me what do we do to sort it? C dot sort, yeah?
Yeah.
And that's it. Return C.
Can see.
Okay, so this is one way of doing it, yeah? It's quick, right?
Is oh yeah, A plus B.
Yeah. A plus B will become this. Yeah. 1, 3, 5, 7, 9, and 2, 4, 6, 8. This is a big list. C will become this list, and then I sort it, and it will become this, and I return C. Yes.
Yes.
Okay, but this is so this if okay.
Yes.
If the size of this is big A, the size of this is big A, big B. So the entire
Big
C,
B.
yeah, the size of C is what?
A plus B.
So the C is A plus B, yes, exactly. And the sorting algorithm generally
What
takes
is the O?
big O. Remember we talked about big O? The complexity of this is O n log n, right? If there are any elements, if we want to sort a list with n elements, this is complexity. So this will be OC log C, where C is A plus B. Okay? This is the one way of doing it. Now we have a better way of doing it because these two lists are sorted. Okay? These two lists are sorted.
That,
So
that
how about
better.
look? How about I want to see here? Yeah, I want to see here. How about I have
See? I told you it
Yeah.
works better.
look? How about that? I put in a. I have two hands. Left hand here, right hand here. Okay. Okay. So I compare. Is one smaller than two?
Yes.
Okay. I put the smaller one. That's one here, right? Yeah.
Yeah.
And I move this left hand there. Okay.
Yeah.
Is 3 smaller than 2? No? Is 2 smaller than 3, right?
Yes.
I always put a smaller one here, up 2. And then I move this to here, right? 2 hands, yeah? 3 and 4?
3 smaller.
Yeah, 3 and smaller. So I put a 3 here and I move the 3 to 5. Do you get it? Yeah? And then 5 and 4? 4 is small. 4 is smaller, right? So I put a 4 here and I move it. Do you see it? So I have 2 hands. Which hand is smaller? I always put a smaller hand and move that thing until it reaches the end, yeah? Do you see it? Because it's already sorted and I can do this. Yeah, do you see it? Because every time I left hand and right hand, they're both pointing to the smallest element in their list. Am I right? Do you get it? If 1 is the smallest of this A list, B is the 2 is smallest in this list, right? Yes?
Yeah.
Then I compare 1 and 2. 1 is smaller than 2, so means that the next number should be 1, right?
So the list should be in order.
Yeah, it should be in order, yes. Okay, so we can do this. Define.
What happens if they're the same number?
What do you mean same number?
In each list, if they're the same number.
Oh, there are two numbers the same, yeah? If I 4 here. It doesn't matter. If it's small, if it's not smaller, you can pick anyone. If it's the same, you pick anyone, yeah? And then move it. It also works, right? Define. Good question, by the way. That's a very good question. Merge A, B, right? Okay, so now we have a C. Yeah, C equals the empty at the beginning, right? Okay, now we need to I, J, L, A, L, B. These 4 variables. I, J will be the beginning, 0, 0.
Yay.
0, 0 means the first element, yeah? L, A is length A and length B. So I want to get the size of both, yeah? And then I need, what I need to do? Y, I smaller than LA and J smaller than LB. So when these 2 pointers are not going to the end, right? And then I need to compare. If AI, look, if AI, the pen, is smaller than BZ, right? Then I need to put this number C dot append, or we can do this C plus equals, put this AI, right? So we put this 1 there, and then I plus equals 1. And move this left. Otherwise, you'll be AI will be bigger than BJ. Now we need to put these B numbers, BJ number there, and then J plus equals 1. Okay? Now, but
Do you have any return?
not yet. So the problem is that, look, this is N. So if the length, one is bigger, one is longer, the other is smaller, right? So this J will apparently may reach here faster. Then this loop will end, right? So we need to check if there are remaining items in both lists. So we can do this by Y. Go this way, okay? Y what? Yi smaller than LA. If it's still there element there, then I need to continue pushing this element to the end, and the I plus 1 equals 1. And then the same as the LB. Yeah, J smaller than LB, and C plus equals BJ, and J plus equals 1, right? And what's next? What's the last bit? You can guess. Return, yeah, return. Which number is it? What we are doing here? What do we do? What are we doing in order to return the list? Which number? Which element? Which list we need to return? Take a guess. Look, what we are doing here? What are we doing here? We are trying to put the element, put the next smallest
Is that
element.
L or C?
L? Which L? Where is L?
Is that L or C?
Y. I smaller. Y.
I mean, and that
C.
C then.
Yeah, because it's C. Yeah. You see? So, just take. So this complexity will be just A plus B. Yeah. You see? This complexity is A plus B. Why? Because I have two pointers. My job is move them to the end. And just one scan, that will be A plus B, right? Yeah, so it's faster, yeah? It's a bit faster than previously. It's OC, right? It's basically the OC. Remember previous one is O what? C
N.
OC log C, right? Now we are OC, so which is faster? Which is faster?
Yeah.
Which one? This one, yeah, of course. So, yeah, of course, the OC is faster, yeah, because OC is this one, and OC log C is here, yeah. Okay, so any questions so far? Do you get it?
Yes, babe.
Any questions?
No.
Really? Okay, so I'm going to test you. Okay, so what's this bit doing? Just can you say what does it mean? What's this bit doing?
Like if one is smaller, you do the smaller one.
And put a smaller one in the list, yeah.
Ew,
And then move the corresponding pointer forward, yeah.
yeah.
Until it reach the end, right? LA and LB. This is the length of it. Well done. Good job today. Okay, okay. Okay.
Bye. Oh yeah, baby. Yo.
Okay, enough.
Yeah.